So we're going to be looking at the guide for the upcoming quiz on linear equations. There's a variety of stuff we need to do for this quiz, so there's a lot of different kind of pieces, but they all revolve around basically how to manipulate or find out the equation of a line, either from points or from a graph. So we're going to be focusing on the point first, about how to get the equation of a line through the points, and then we'll work with the graph stuff a little bit later. So what we're finding here is this little slope-intercept equation of a line that goes through the indicated points given to us. So in this case, 0, 2, and 1, -3, and then this point and this point. So every line has an equation to go with it. Every line has an equation that describes it. And that's what we're trying to find out. We're saying if these 2 points are on a line, what's the equation of that line? And to do that, we have to find 2 things. We have to find the m, which, if you don't remember, is the slope. That's how inclined the line is. And the b, which is the y-intercept. That's kind of like where the line sort of starts, for lack of a better word. Or it's how far up the line goes on the y-axis when it crosses it. And so to start all these problems, the first thing you want to do is find the slope, if it's not already given to you. So the first thing you always do when trying to find the equation is find the slope. And in this case, we have a formula for that equation. The slope is y1 minus y2 over x1 minus x2. Now you could say y2 minus y1 over x2 minus x1, which is usually how it's written, but I find the 1, 2 thing goes a little bit easier in the memory. So basically all it revolves around is subtract your y's on top, subtract your x's on bottom, and then that's your slope. So if we look at this here, we have, remember points go xy, so xy, xy. Now it's kind of counterintuitive because when we write it as the fraction, the y's are going to go on top, not the x's. Let me make that a little bit better, y there. There we go. So remember, the y's go on top, not the x's. So in this case, I'm going to go 2 minus -3. So 2 minus -3. And then on bottom, I'll go 0 minus 1. Now, the top order doesn't matter so much. I could do 2 minus -3, or I could do -3 minus 2. But whatever I do on top, I have to repeat on the bottom. So if I do 2 and then -3, on the bottom I have to do 0 and then 1 to remain consistent. And then vice versa. If I did -3 and then 2 on top, I'd have to go 1 and 0 on bottom to remain consistent. So let's see what happens here. 0 minus 1, that's -1. Remember, double negative like this, 2 minus -3 makes one big positive. So it's 2 plus 3, which is 5. And that gets me -5 as my slope. Now, the next part, this is my m, so I found my m. The next part is to find your b. Now, here's a trick here. That your b value, remember this is your y-intercept, right? So this will always be 0, comma, something. That something is your b, because the y-intercept is always the point 0, comma, a number. And that number is what we use as our b value, because that's actually the y-intercept. We don't really use the 0 because we know it's 0 because it's the y-intercept, so we just use the number itself. So if you already have a point in that form, then you're already given your b. Like in this case, 0, comma, 2. Well, this is 0, comma, something, so that means this 2, that's my b value. So my equation is just y equals m, which is -5, x plus b, which is 2. And then this would be my answer. Now, this shortcut won't always happen, but be on the lookout for points that are in the form 0, comma, something, because that gives you a free b value that kind of eliminates half the work, if not a little bit more. So let's see about the next one here. Let's set up our fraction. Again, we're going to go y is on top and x is on bottom, so -2 and 5. So -2 minus 5, those are my y's, and -4 and -3. So -4 and -3, so minus -3. And then we're going to subtract, so -2 minus 5. So I lose 2, and then I lose 5 more, so I've lost 7. And then here, remember, double negative makes a positive again, so it's -4 plus 3, which is -1, and this just gives me a positive 7. So that is my m value. That's my m part of the equation. Now, I don't have a shortcut here. There's no 0, comma, something point. So I have to do it the long way. Now, to do it the long way, what you have to do is you have to pick a point of reference. And that point of reference is one of the points that you were given. So you can pick any of these pairs of points here. I'm going to pick this one right here. So -3, comma, 5 is going to be my point of reference. And then, of course, 7 is my slope. So I'm going to look at this equation here. Y equals mx plus b. This is what I ultimately want. I want an m and a b. Now, I know an m. And if I could, I would solve for b, but I can't really solve for b because y and x are still in there. I mean, you can only solve for a variable if there's just one number to solve for. Like if I plugged in m, this becomes y equals 7x plus b, and I said solve for b, well, you can get b by itself, but you can't really get a number for b. So what you're going to do is temporarily plug in a y and an x from the reference point that you picked. So 5 would go in for y, negative 3 would go in for x temporarily, just so that you can solve for b. And the reason that this works is because we know that this point is on the line. Remember, this equation holds true. This equation works as long as the point is on the line. So I can't just pick any random point. I have to pick a point I know is on the line, which is good because I have two options here, because I know that both these points are on the line. So I'm going to temporarily plug in 5 for y, temporarily plug in negative 3 for x, and see what I get when I try and solve for b. So this becomes negative 21 plus b equals 5. You're going to add 21 to both sides to get rid of it, and you get 26 is equal to b. So my equation is y equals 7x plus 26. So finding your b value doesn't take too much extra work, but you do have to pick that point of reference to plug in temporarily. And then your final answer, remember, is not just two separate numbers, it's the entire equation. Y equals m, whichever number you get, x plus b, which is whatever number you get. So you have to make sure to plug in both those values into your equation in order to make it work. Number 3, again, same idea, to find our slope first. So y and y, so 2 minus negative 4. X and x, so negative 2 minus negative 5. Whoops, try this again. Negative 5. So remember, the double negatives make a positive, so plus there and plus there. So 2 plus 4 is 6, over negative 2 plus 5 is 3, and that just gives me a solid 2. So that's my slope. I don't have a shortcut here, so I have to go back to the long way. I'm going to pick this as my point of reference, so negative 2 comma 2. Remember, this is my y, and this is my x. So I'm going to go to my equation, y equals mx plus b. Plug in the number for y, which is 2. Plug in the number for m, which is also 2. Plug in the number for x, which is negative 2. Lots of 2's here, plus b. And then go about solving it. So 2 times negative 2, that's negative 4, plus b equals 2, and then add 4 to both sides, and you get 6 is equal to b. And that would be my b value, and so my final answer is going to be the form of equation y equals 2x plus 6. And that is my final answer. Again, your final answer has to be in the form of an equation, not just two separate values. Last one for these here. Y and y, so 1 minus 3, and then x and x, so 5 minus negative 5. Remember, the double negative again makes a plus, so we get negative 2 over, and then 5 plus 5, which is 10, and this comes out to be negative 1/5. And so then I'm going to pick this as my point of reference. Again, it doesn't matter which one you pick, just pick the one that looks easiest to you. So 5, 1 is my reference point, so y equals mx plus b. Y is going to be the 1. M is negative 1/5, as we just found out. X is going to be the 5, and then plus b. Then we solve. So negative 1/5 times 5, that's negative 1 plus b equals 1. And then you add 1, so you get 2 is equal to b. So my final answer is going to be y equals negative 1/5 x plus 2. So again, the first step is always finding your slope. You cannot proceed until you find your slope. Once you have your slope, then pick a point of reference if you don't have the shortcut, then go about finding your b, and then just plug them into the equation as you're done. Again, you're not getting a single number here, or you're not getting two numbers here, you're getting an equation that you want to be labeled at the end. And if you do have a shortcut like we had in the first one, make sure you take advantage of it because it saves yourself a fair bit of work. So if we go on to the next one here, this is another way of describing a line. So this is the point-slope equation. So the equation we just got through doing, that's called the slope-intercept equation because it uses the slope and the intercept. And this is called the point-slope equation because it uses the slope and it uses a point. Now this is considerably easier. It's just, all this is though, is just another way of describing the equation of a line. It's another way of talking about the line rather than just having 2 points or just having a slope-intercept equation. It doesn't make it any better or worse. It's just a different form, a different way of talking about a line. Now, the first step here is still the same. You have to find your slope. Let's go ahead and do that. 5 and 8, so 5 minus 8. Take my y's and subtract them. 4 and negative 3, so 4 minus negative 3. 5 minus 8 is negative 3. This, remember, double negative is a plus, so 4 plus 3 is 7. So this is my slope, negative 3 sevenths. It can't be reduced anymore. Now, I do still pick a point of reference, but I don't have a b to solve for. So here's what I do. y1 and x1, these right here, those are the x and y coordinates of my reference point. M is obviously my slope, and then y and x just stay y and x. So there's actually two possible answers for this, depending on which reference point you pick. Let's say I pick this as my reference point. My answer would be this. Y minus the y coordinate, which is 5, is equal to negative 3 sevenths times x minus the x coordinate, which is 4. This could be one possible answer for this problem. This is the point slope equation of this problem using the point 54 as the reference point. That's a 7 down there. Now, what if I pick the other point as a reference point? Well, it would look like this. Y minus 8, because that's the y coordinate of the next point, times negative 3 sevenths times x minus negative 3, or you can say plus 3 if you want to, that's fine. This could be another possible answer. So both these answers are correct. It just depends on which point of reference you pick. Like I said, it doesn't matter which one you pick as long as you pick one and use it right. For the rest of these, I'm just going to use one answer. I'm not going to do them both, just to speed up the video a little bit. So, but first thing first, as always, find your slope. So y minus y, 7 minus negative 2, and then x minus x, negative 1 minus 8. Remember, double negative makes a big positive, so 7 plus 2 is 9. Negative 1 minus 8 is negative 9, and this comes out to be a negative 1. 9 divided by negative 9 is negative 1. That's my slope. I'm going to pick this as my reference point. So y minus 7 is equal to negative 1 times x minus negative 1. Or if you want to write it in a better way, it'd be y minus 7 equals negative 1 times x plus 1. This could also work. Both these answers are the same. Or if you want to be really fancy, you could do this. Y minus 7 equals negative x plus 1. That also works because remember, you don't really have to write a 1 here if you don't want to. You can just write the negative symbol. We don't really write 1s in math all that often unless they're being added or subtracted. If they're being multiplied, we just kind of ignore them. And the negative ones, we just ignore it and just leave the negative in there. But all three of these answers would be correct. Next one here, again, y minus y. So 7 minus 3 over 5 minus negative 1. 7 minus 3 is going to be 4. 5 minus negative 1. Remember that double negative makes a big plus, so it's going to be 6. We reduce this by dividing by 2. So divide the top by 2, you get 2. Divide the bottom by 2, you get 3. So our slope is 2/3. So what do we do here? Well, we make our slope-intercept equation. So we go, I'll pick this as my reference point. So we go y minus 7 is equal to 2/3 times x minus 5. Again, you could use the other reference point, but I'm just going to leave it as this one here just because the other reference point is just as easy to do. So, and then finally here, number 7, again, negative 5 minus negative 15. Get your y's on top. And then negative 3 minus 3. So here, remember, double negative means one big plus. So negative 5 plus 15 is going to give me a positive 10. Negative 3 minus 3 is not 0. Again, you lose 3, then you lose 3 more, so you've lost 6. So it's a negative 6. And if you divide these by 2 to reduce them, you get negative 5 halves. Or sorry, negative 5/3. My bad. So that's your slope. I'm going to pick this as my reference point because it has a positive number in it. So y minus negative 15, or plus 15 if you want, times, or negative 5/3 times x minus 3. And there's one of the possible answers. So it's a lot quicker than slope-intercept form. And in fact, if you continue this out, you can actually solve this to be in slope-intercept form. Like for example, number 5, just distribute the negative 1 and then add the 7, and then you have it in slope-intercept form. Because all slope-intercept form is really taking the point-slope form and solving for y. So getting y by itself. If you can take these equations and get y by themselves, you're going to end up with slope-intercept form. But make sure you know the format of both. Again, point-slope uses a point and the slope. Slope-intercept obviously uses the slope and the intercept. The next one is getting the equation from a graph. So we'll start with slope-intercept. Remember, slope-intercept needs an m, or a slope, and a b, or a y-intercept. If you get those two, you're done. So Let's first find the b, because that's usually easier. The b is the y-intercept. So the b is what point does the line cross the y-axis? Remember, this is the up and down. It's the y-axis. Well, that'd be right here. What's that point? Well, that point is -3. Well, the point is 0, comma -3, but we don't really need the 0. So we just need to say the b is -3. That's the point on the y-axis where it crosses. Easy enough. The slope, remember, the slope has a definition of being the rise over run. There we go. Had to get my pen back. So the slope is rise over run. And it's between any point on the line. So all I need to do is pick 2 points on the line and figure out how far up and over to go to get from one to the other. Now, when I say a point on the line, I mean you don't want to pick, say, this point right here, because you don't exactly know where that point is. That point could be 2.5, it could be 2.3, it could be 2.46. We don't exactly know. You want to pick points that you know the coordinates of for sure and solidly. Like, for instance, this one right here. This is the point 0, comma -3. I know exactly where that is. That's a good point to pick. You want to pick points that kind of go through the crosshairs. And if we look through here, this one's pretty close, but still missing that mark there. So this one right here, that's 7, comma 1 exactly, so that's a good other point to pick. So I want to figure out what's the rise and run from here to here. So we go up 1, 2, 3, 4. And since we went up, it's a +4. Remember, this little grid can help you out. Up is positive y, right is positive x, down is -y, left is -x. So since I went up, that's a positive rise, a positive number. Then I'm going to go right, 1, 2, 3, 4, 5, 6, 7. Another positive number. Now, if I went down to the left, I get the same answer. But if I went up and to the right, I get 4 and 7. So my rise is 4, my run is 7, so my slope is 4/7. So my equation for the slope-intercept form for this line would be y equals 4/7 x minus 3, or plus -3 if you want. That is the slope-intercept equation. Again, all you need to do is find the b and the m, and the b is going to be pretty self-apparent because that's going to be the point where it crosses the y-axis, and the m just takes a little bit of counting. Now for point slope, you also need the slope, so this is used for point slope too, and then you just need to pick a point, any point you want on the graph. Again, don't pick a point you don't know for sure about, just pick any point that you know the coordinates of, like let's say this one. So that's the point 7, comma 1. So I'm going to use that for point slope, and I'm going to use the slope for point slope, obviously. So my equation is going to look like this. Y minus the y coordinate, which in this case is 1, is equal to the slope times x minus the x coordinate of the point I picked, which in this case is 7. And then there's my answer. So again, from a graph, it really doesn't take much work at all to get the equations. You just have to know what to look for. For the slope-intercept, you're looking for the intercept and the slope, obviously. For the point slope, you're looking for the slope, again, obviously. And you need a point on the graph. Again, it doesn't matter which point you pick. So there's a lot of different answers for this one. There's many different answers for this, as long as you can find a point to fit on there. In this case, 7, 1 was the point I picked. I could have picked 0, comma -3. I could have picked a few others as well if I wanted to kind of do some guesswork. But this was the one that I chose to go with, so this is the answer that I get. And then the last page here, so the next one is going to do what we just did backwards. So it wants to actually graph the equation, it wants to graph the line. So when you're graphing a line, you have to do 2 steps. You have to first graph the b value, and then you get the other points by using the m value. So the b value, the adding part, and the number that's being added or subtracted, that tells you, this 3 right here, tells you where to start on the y-axis. So that tells you what number to place your first dot on the y-axis. In this case, it says place it on +3. So I'm going to go up to 3 and place a dot right there. That's my y-intercept, so that's going to be where I start. Now the slope, which is -1/2, the slope tells me my rise and run, remember. So this 1 tells me to go up or down, and this 2 tells me to go left or right. Now, the negative can be applied to either one you want. It can't be done to both because there's only one negative, but you can apply the negative to the 1 or the 2, whichever one you want. I'm going to apply it to the 2. So I'm going to say that this is a +1, so it says go up 1, because remember, up is a positive direction. And this is a -2, so I'm going to say that means move left 2, because remember, left is a negative direction. So up is positive, left is negative. Positive or negative is a negative fraction. So I'm going to go up 1 and left 2. Boom, boom. And there's another point. And I can go again from this same point. I'm going to go up 1, left 2. Up 1, left 2. up 1, left 2. And I can keep doing this on and on and on. Now, just to show you that it would have worked other way as well, I could have switched this up and I could have reversed both. I could have said go down 1 and right 2. I could have said that and I'd still get the exact same line. So if I start here, I go down 1, right 2, down 1, right 2, down 1, right 2. I get the same line, just the other half of it. And so my full line would look something like this. Kind of hard to graph it with the little mouse I'm doing, but that'd be how you connect. You just get a bunch of dots, as much as you need to connect your points, and then just connect them all straight through. As you can see, I kind of curved a little bit here because I was kind of wavy when I was doing my line. But again, I'm using a mouse here, so just did the best I could. So just remember, again, when you have your slope, if it's a negative, one of the directions, not both, but one of the directions have to be a negative. Another thing to notice is that if your slope is a negative, your line is going to be going down as you read it left to right. So if you go left to right like you would read a book, a negative slope means your line is going down. A positive slope means your line is going up. So this line is going down and it has a negative slope, so that's a check to make sure that I'm doing it right. And the last one's a word problem. So when it says what does it mean in context, that just simply means what does this number represent? It's not some random number. What does the number actually represent? And this should be a B here, not a C, so it's a misprint on my part. So what does the number actually represent? And I should probably make that an actual B, not a D. So what does the y-intercept in this equation represent? Well, let's first look at what the equation means. So this says it makes y dollars, so y is the dollars, for driving x miles. So x is the miles. And this is the equation of how they get their dollar amount. What is the y-intercept and what does it mean? Well, first off, what is the y-intercept? Well, the y-intercept here is this 3. Remember, the y-intercept is what's being added or subtracted. So my y-intercept is 3. Now, what does that 3 mean? Well, remember, the y-intercept is the point, try to write this as best I can, the point where x equals 0. That's kind of another meaning of the y-intercept, is the point where x is 0. Well, what does x represent? Well, x represents the miles. So this 3, remember, y is dollars and x is miles. So if 3 is the y-intercept, that means this 3 represents the dollars for going 0 miles. Because remember, this 3 is when the x is 0. And if the x is miles, that means it's the dollars for going 0 miles. Or put another way, it's the flat fee, or the flat charge, or the one-time cost. So if you just get in the cab and go like 2 feet, you're going to pay at least $3. Or if you get in the cab and just go like 1 inch, you're still going to pay at least $3. That's called the flat fee or the flat charge. And that's usually what the y-intercept represents. The y-intercept represents the flat fee, the flat charge, the one-time cost, or the starting amount. Basically, it represents what happens once in the problem. So you pay that $3 once. You don't pay it over and over again. You pay the $3 once, and then you pay an additional amount depending on how many miles you go. So anything that just happens once, again, flat fee, initial value, starting amount, those are all y-intercepts. So the 3 here represents the dollars for going 0 miles, or a $3 flat fee. Now, what is the slope? Well, the slope is this 0.95, because that's the other number, that's the m, that's the number attached to the x. The slope is always multiplied to the x. Now, what does it mean? Now, the slope has a very specific meaning. The slope can be read as y per x. And what do I mean by y per x? I mean the y unit per x unit. What's the y unit here? Well, it's dollars. So dollars. What's the x unit here? Well, it's miles. So what does the slope mean? The slope means dollars per mile. So this is 0.95 dollars per mile, or dollar per 1 mile if you want to put it that way. So basically this means you pay 95 cents to go 1 mile if you want to put it into a sentence, which you probably should, but I'm just doing it to kind of piece it apart here. So the slope's description should always have something like per in it. The slope is always something per something. It's y per x. So dollars per mile, ponies per car, gallons per minute, feet per second, that sort of thing. The slope is always something per something, and the somethings are y label per x label, dollars per mile in this case. So remember, y-intercept is one-time cost, slope is repeated amount. Anything that repeats over and over and over and over and over again, anything that's happening again and again and again, that is what the slope represents. So dollars per mile because you're going to pay a certain amount, in this case $0.95, every single mile. Not going to happen once like the $3, it's going to happen every single mile. So that wraps out this one. Again, a lot of different things to do here, but they all revolve around knowing those equations, especially the slope-intercept equation and kind of what the numbers mean and how they play together. Hope you enjoyed the video. Have a good day.